So execution of program LCD interfacing with PIC microcontroller. So this is the interfacing diagram of LCD with PIC microcontroller. So pins are shown here for PIC microcontroller. So we are interested in these pins. These are the data lines of LCD 16 by 2 LCD D0 to D7 are connected to port B of PIC microcontroller. RS terminal of PIC microcontroller is connected here. So RS is RC0 pin, port pin, and enable terminal of this LCD is connected to an enable terminal, that is RC1 pin of this PIC microcontroller. R/W bar is connected to ground. So this pot is connected to vary the brightness of this LCD. So reset circuit and the clock circuit can be connected to this PIC microcontroller. But we are interested in data bus, enable terminal and RS terminal. So using this interfacing diagram, we can write a program to display string on this LCD. So first we have to include this file p18f4550.h, that is header file of PIC microcontroller. Here instead of p, now new versions need this PIC 18f4550. This is PIC for PIC. So this P can be replaced with PIC. So we'll define this pin, RC1 pin of port C with a variable name LCD underscore enable and RC0 with variable name LCD underscore RS. So first we'll write a small delay program. So here variable I is varied from 0 to 5000, which will generate a small delay. So this is the delay function we are going to use, and whenever we want to use RC1 pin, we'll write LCD underscore enable, and for RC0 we'll write LCD underscore RS. So strings which we want to display are initialized here, stay and save. Now we'll write a command, send command subroutine program or function. So first we are selecting command register. So LCD RS terminal should be at logic 0. We'll call a delay. Then we'll send an enable pulse to enable terminal high to low pulse. So enable is 1, call delay, and then place this command on port B of LCD. Then call a delay and enable terminal should be 0. So we are passing this argument, command argument, to this particular function, and that is placed on this port B. Similarly, we'll write a function to send the data. So write the data in data register. Here argument used is LCD data. So to select the data register, RS terminal is 1, call a delay. Send enable pulse to logic 1, call a delay, and we are placing this data on port B. Call a delay, this enable is 0, call a delay, and end this function. Now we'll write a main program. In main program, some variables which we are going to use are declared here. This B port we are using as an output port. So we are initialize TRISB register, TRISB register, and this RC0 pin is declared as an output pin. RC1 pin is also declared as an output pin. To initialize LCD, we'll write a command 38H to LCD. So call this function send command P. Then the command 0EH will transmit. So again call this send command, and the lastly command 01H is transmitted. So next is in while one loop we are writing this, we are sending the string continuously. So first string will display from sixth character position. So for that, address of that is initialized to p value, and we are sending this command to command subroutine or function. Then we are reading one by one this character. We are storing ASCII value of character in S variable, and we are sending it to the data function. So that particular character will be displayed. Now the next string will display again in the next row of LCD from sixth position. So that address is stored in variable P, and we are sending this, we are calling the command register. So here we are using initializing this S variable. We are reading one by one character and sending it to data variable. So here in this MPLab software, the project is created, the .c file is created, and the same program is written here. I'll build this program. So there is no error, same program is stored here. No error, hex file is created. So we can download this hex file using PIC loader. So after downloading, you'll observe the output on LCD display.